Welcome back, 6th graders, to STEAM Camp. Today, we are going to focus on the T in STEAM, which refers to technology. How are you today, Alexander?
Excellent.
Very good. My name is Mrs. Koenig, and I am a teacher on special assignment. My team and I are responsible for teaching teachers about STEM opportunities that we have here in RUSD. Some of the things that we are responsible for are Legos, Ozobots, Spiros, and Microbits. Hopefully you guys have had a chance to experience a few of those. I'm excited to be here with you today as we explore technology and the endless career possibilities.
Nice to meet you, Mrs. Koenig.
Nice to meet you too, Alexander. We have a fun-filled day planned for you. We are going to take a look at some vocabulary words that will give you some background knowledge to technology. We're going to do some origami art that requires you to follow an algorithm. We are going to complete some work in your journals. We're going to do some partner pair share talk. We are also going to hear from some students from CBU. Then you will have access to a choice board at the end of the day where you will be involved in coding, and you also have the opportunity to look at some other careers that are available for you in technology. One other opportunity will be for you to complete a different origami art activity. But mostly today, you are here to learn about the process of technology and what it involves. Technology involves the 4 C's: the power of yet, algorithms, and of course, debugging. Our goal for the day is to expand your knowledge of what technology is. All right, so some things that you're going to need for today is obviously a growth mindset. Alexander, have you ever heard of the power of yet? The power of yet is a growth mindset that focuses on things that you have yet to learn. This week, we are exposing you to all of the components of STEAM to help you grow your mind to some of the STEAM opportunities or possibilities that you have yet to learn. Alexander, do you have a willingness to have fun?
Yoke is my middle name.
An elbow partner?
An
Alexander,
elbow partner?
will you be my elbow partner? You will also need your journal, a pencil, and you are going to need some skills for today as well. I mentioned this earlier when I talked about the 4 C's. The 4 C's are important 21st century learning skills that everyone needs to have. These skills are essential to collaborating, that means you're working together, communicating, being able to talk and tell each other what you need and what you want.
Does texting count?
Creative skills, we all like to be creative. And then most importantly, critical thinking skills. You're going to need this skill specifically in technology because it requires you to problem solve. How can we make things better? In computer science, you never code alone. The work is challenging and it requires you to have a growth mindset. All right, so because 21st century learning skills are essential to our growth, what I want you to do is take out your journals. You're going to take out your journals, and I need you to take out a pencil or a pen. In your journal, you're going to open it up to the first page, and what I would like for you to do is think about yourself and think about the skills that you have. When we talk about collaboration skills, we talk about communication skills, being creative, or critical thinking skills. Which one of those 4 is your strongest skill, and why do you think that's important to use? So now that you guys have finished writing in your journal, we're going to continue using our journal. But we want to start by defining what technology is. So, Alexander, what do you think technology is?
Technology is all about video games and computers.
Yes, Alexander. Video games and computers are definitely products of technology. Woo! But actually, technology is so much more than that. Technology is the use of science and problem solving. So remember when we were talking about those critical thinking skills? Technology is the skills, methods, and processes used to achieve our goals. So, think about it. Technology can be as grand as flying a drone, but also technology is as simple as finding a way to bring water into our homes. All of these processes involve technology. And again, these technology processes involve the 4 C's, the power of yet, algorithms, and of course, debugging. So today, as we continue to expand your knowledge of what technology is and what it can be, we are going to introduce you to some amazing engineering students at CBU, which is Cal Baptist University, located here in Riverside. We had the pleasure of interviewing some of those students as they described to us some of the projects that they're working on. In these interviews, you will notice how they had to use the 4 C's, algorithms, and debugging to make their projects successful. So let's take a look at the first interview. Wow, Alexander, check out this amazing place. Look where we are. Did you know that we are here on the campus of CBU? Have you ever been here before? This is your first time? I know, go Lancers, right? Yes, this is so exciting. Students, we are here today at CBU at the College of Engineering. And Alexander and I have the opportunity to interview some students who are part of the engineering college. These students are working on completing a passion project that they have created. These projects are related to their major, but it's also connected to the careers that they are pursuing later on in life. So today, Alexander, we are going to interview these students and we're going to find out how these projects connect to careers that hopefully interest you. We have some students that are here to tell us about some wonderful projects that we're working on. So go ahead and introduce yourself.
Yeah, my name is Josh Thompson, and I'm a civil engineering major here at CBU.
I'm Bernie Estrada. I'm a current civil engineering student here at California Baptist University.
Can you tell us what career path are you choosing?
Yeah, so I would love to work as a civil engineer in the future, actually in the mission field. I have an internship with an organization called Samaritan's Purse, and I'm going to be in Louisiana rebuilding homes that were destroyed by hurricanes in the last couple of years.
So I'm a civil engineering student. I would like to work in project management, and that's different from design, but it's still the basics of having civil engineering. I plan to also get field experience here in Southern California, but I would like to reach out to other countries to help with water resources, with structures, infrastructure, and helping in things that other countries don't have that we do benefit from.
So do you want to tell us about the project that you're working on?
So I am the captain of the steel bridge team, which they assigned us the task of building a 20-foot long bridge that has to hold 2,500 pounds, and it has to meet certain dimensions, be certain height, length, width. All the pieces have to fit into a certain box, and there's a lot of bugs to work out. So we were running a bunch of different designs and a bunch of different makes and models to find the perfect one that was light enough, that was going to fit all the dimensions, that was going to support all the weight that they were going to be putting on it.
Very good. So how many members were on your team?
It started off with 2 teams of 6. We were working on different designs in the design phase, and then once we chose our final design, we all came together as one big group of 12 and worked on it and got it done quick.
What does it take to be a team member and to accomplish your goal together?
Yeah, so basically what it takes is just diligence, not being lazy, putting your part, making sure that you're not piggybacking on everybody else, being willing to put in the hard work necessary to get the job done, being willing to do whatever it takes, no matter how long or how hard the work may be, to make sure that it's done well and it's done according to the specifications of the competition rules.
How important of a role is communication in that?
Oh, it's super important. I mean, if one member is doing something by himself and the other members are not in agreement, or if one member is designing something and the other members don't agree with that, that really sends chaos into the team. Even in the construction part, if you're building something and you don't comply with the design, the original design, the finalized design that you chose, that sends chaos into the team. And without communication, the team doesn't function properly.
All right, so something that we're talking about with the sixth graders are algorithms. So talk to us about how you used algorithms in the creation of your bridge.
We did during that design process, yes. So you got to use them to analyze the bridge and change up your formulas and equations to analyze the different reactions that are occurring. When you put all that weight on it, there's going to be an upward reaction from that bridge as well. So you got to analyze and calculate all those different reactions that are happening using algorithms.
You were part of this team. Did each team member have a specific role?
Yes, we tried to divide it as much as possible. Mine was, originally it was structural analysis. I had to make sure that the structure was going to stand. And then other members had different parts. One was foreman, one was the communications director. Everybody had their part. Everybody had their role. At the end though, as long as you can help out in whatever you could, then yeah, for sure, you could help out the team captain, you can help out the foreman. Everybody put in their part to make sure that it got done.
We're wishing you the best of luck. And thank you so much for being here. We appreciate it. Thank you. All right, now that you've had a chance to watch this video of the CBU student, what I want you to do is I want you to turn to your elbow partner, and I want you, the two of you, to have a 2-minute discussion. Here's what I want you to discuss. What is something that you learned from the student at CBU? All right, take 2 minutes and discuss that. All right, now that you've had a chance to actually see somebody from CBU explain to you how they use some of the 4 C's, debugging, and algorithms, let's talk about some other important terms that we're going to talk about today. First of all, we're going to talk about what computer science is. We're going to talk about computational thinking, algorithms, and of course, coding. Let's begin by defining what computer science is. What is computer science? Computer science is the study of computers and algorithm processes, including their principles, their hardware and software designs, their implementation, and their impact on society. So, as you can see, they did mention those computers that you talked about, Alexander. I would like for you to take your journals out And I want you to use the words in your word bank to help you fill in the sentence frame that defines what computer science is. Now let's move on to what is coding. Coding is the process of transforming ideas, solutions, and instructions into language that a computer can understand. All right, we're going to do the same thing in our journals. I want you to take those pencils out and use the words from your word bank to fill in what the definition of coding is. All right, the next word we're going to focus on is algorithm. What is an algorithm? All right, an algorithm is a list of rules to follow in order to solve a problem. So let's take a look at this picture here on the screen. What do you see? Alexander, what do you see?
It's a peanut butter and jelly sandwich. Sure glad it's not an egg salad sandwich.
Funny, Alexander. All right, so we're going to talk about something right now that is called the peanut butter and jelly effect. Okay, Alexander, are you ready to listen?
I'm as ready as I'll ever be.
Very good. I want you to follow along as I read out loud. The peanut butter and jelly effect. Imagine you get home from school and you see your very own robot standing in your kitchen, waiting for orders. That would be cool, right? You're hungry, so you ask your robot, let's call our robot AwesomeBot 3000, aka Bot, and you want it to make a peanut butter and jelly sandwich. I require further instructions, Bot says in its electronic robot-y voice. Everything for your peanut butter sandwich is laid out on the kitchen counter. So you say, okay, go to the counter, get the bread, put the peanut butter and jelly on the bread, and bring it to me. So Bot rolls to the counter. Did I mention it has wheels? Picks up the jar of peanut butter, picks up the jar of jelly, and puts both of them on top of the bag of bread. Computers are super literal. If you want a bot to make a sandwich you can actually eat, you have to give it something like this. Locate the bread, open the bag, remove 2 pieces, lay pieces flat on the countertop, side by side, roll 2 feet to the right, locate the drawer, open the drawer, remove the knife from the drawer, close the drawer, roll 2 feet to the left, locate the peanut butter, open jar, insert knife into peanut butter. You get the idea. To start coding, you have to know programming language, but just as important, you have to understand how computers think so that you can give it instructions to get it to do what you want, which basically means that you have to plan, problem solve, analyze information the way a computer does. Once you understand how computers process information, you will understand what they can and can't do. Knowing that will make coding much easier. Okay, Alexander, it's time for you to use your creative skills. Are you ready? Alexander, were you listening? Okay, wait, let's do another activity. All right, students, it's time for you to get that journal back out. And I want you guys to also participate in this activity. I want you to turn to the page in your journal where it says the silly bug page. And what I want you to do is I want you to read the directions and I want you to follow the directions exactly. You guys are going to do an algorithm right here. It's called My Silly Bug Algorithm, all right? You're gonna draw a triangle for the body. You're gonna add 4 eyes, add 4 legs, add a crown, and add some wings. All right, I'm gonna give you 2 minutes to complete this assignment.
Hey, mine looks different.
Great observation, Alexander. All right, so what I want you guys to do now is I want you to compare your silly bugs. I want you to turn to your elbow partner and compare your bugs. Talk about how they are different and talk about how they are the same. You guys have 1 minute.
Oh, that's why algorithms need to be specific and detailed.
Very good. So as you can see, you guys all followed an algorithm. Although you had the same algorithm, your outcomes were very different. All right, let's continue with algorithms, and we're going to do a class activity. At this time, your teacher is going to take out an anchor chart and a marker. And what you and your classmates are going to do is you are going to generate a list of steps that is required to make a peanut butter and jelly sandwich. All right? So I'm going to give your class 10 minutes. You're going to tell your teacher in order the steps it takes to make a peanut butter and jelly sandwich.
Ooh, don't forget to be specific and detailed. You don't want a jar of peanut butter in your sandwich.
All right, so now hopefully you and your class have come up with a list of at least 50 steps on how to make a peanut butter and jelly sandwich. But we're going to take a break from that for just a moment. We're going to now talk about something called debugging. And many of you may have heard of this before when you did coding with your teachers in younger grades. But for those of you that haven't, debugging is the process of identifying and removing errors from computer hardware or software. Remember, going back to the growth mindset, making mistakes is a part of life. When we code, coding errors take place. That is why computer scientists use debugging to correct those errors. All right, so I want you guys to take out your journals now, and I want you to complete the section using the sentence frame to define what debugging is. All right, so now that you've had a chance to do that, let's go ahead and put those journals over to the side. And as a class, we're going to go back to that list of 50 or more steps that you and your class created on how to make a peanut butter and jelly sandwich. All right, so what you're going to do with your elbow partners is you two are going to discuss how many steps did it take your class to come up with. That's the first question. Are there 50 steps needed? Do you need more? Do you need less? Would some of the steps be changed? For example, what if the jelly was in the refrigerator? Did you include the step to go to the refrigerator, open the door, take it out? Here's another question. What if the jelly is in a jar compared to it being a squeezable jelly jar? So think about those things with your partner. You will have 3 minutes to discuss those steps. All right, Alexander, did they miss anything? So hopefully you and your classmates were successful in creating a list of steps or an algorithm that was necessary to make a peanut butter and jelly sandwich. But I also want you to reflect on how important it was to use collaboration as a class to create that list. We also used communication to share with each other what our thoughts were. All right, who's ready for some fun? Now it's time to use a more detailed algorithm. Together, we are going to create an origami egg. So, I want you to take a few moments to clear off your desk. At this time, we need to make sure everything is clear off of your desk. You are going to follow the steps in this video. Have fun. All right, boys and girls, now that you have had a chance to learn what an algorithm is, we are now going to use origami to create an egg. But before we begin, there are a few things that I need to introduce you to. A few vocabulary words I need to introduce you to. The first one is the crease. Now, when I refer to the crease, I'm talking about making sure that the ends of your paper touch the corners before you crease the paper to create that fold. That's the first word. The second one is an obtuse triangle. Most of you guys in math should have already experienced what an obtuse triangle, but here is what it looks like in case you don't know. And another word that I want you to be familiar with is a diamond. We all know a lovely diamond, but here is an example in case you need it. And then two other words that you're going to need to know are vertical and horizontal. So think about those lines in geometry because they're going to be important. Now, before we begin, I'm going to ask one last thing of your teacher. I'm going to ask you all to please listen to the directions of the entire video prior to doing it. So you're actually going to listen to it twice. Once to listen for the information, and the second time, then you're going to listen and participate. All right, let's go ahead and get started. All right, so everyone should have your paper in front of you right now. And you're going to notice that the shape is in a square. You are going to use your pencil, and in the corner of the paper on the right, I want you to put the letter F. That is going to be referencing the front of your paper. After you have done that, please flip it over, and you're going to write a B in the bottom left corner. This will be referred to as your bottom corner. All right, so take a few seconds to add those two letters. The F for front and a B for bottom. All right, now you guys have all had the opportunity to add those two letters. What I would like for you to do is I want you to begin by turning your paper over. And now you should be on the bottom. That's the B should be up in front of you. I would like for you to grab the bottom of the paper and fold it so it meets the top. Before you make the crease, make sure that the corners are touching. I want you to rotate the paper so that the crease is now vertical. Again, you are going to grab the bottom and you are going to fold it so that it meets the top. Open the folds and you should see 4 squares. Flip it over to the other side. You are going to take the bottom of the diamond up to the top of the diamond. Make sure that the 2 corners touch. Now you're going to open it up and you are going to rotate it counterclockwise. Again, take the bottom of the paper to the top of the paper. Once again, you're going to open your paper up. You're going to grab the 2 outer corners, pinch them, and pull them to the middle to where they meet in the back. Rotate the square so that the closed point is at the top. Take the bottom of the diamond and fold it to the top. This will create an obtuse triangle. Now we're going to open the triangle. This time you're going to grab the top of the diamond, fold it to the center crease line. You are going to crease the top. Then you're going to open the entire paper back up into a square. You should see the back side. So look for your B in the bottom corner. Grab the bottom right corner and you are going to fold it to the second crease. You will then repeat this step 3 times to do the same thing for each of the corners. Make sure that you rotate your paper 90 degrees clockwise so that it looks like it does in the video. Teachers, you may need to pause right here to allow your students time to make those creases. All right, now you're going to grab the right and the left corner, and you are going to pinch it forward to create a shield-like shape. You are going to grab the first layer of paper on the right side, and you will fold it to the middle crease, creating a small flap. Okay, turn the paper over, and you are going to repeat the same step that we did on the other side using only the top layer of the paper. Again, make sure to crease the flaps down. All right, let's all take a moment and we're going to turn to our elbow partner. And I want you to make sure that your paper and your partner's paper look exactly the same. If you notice your neighbors around you are needing some help, please make sure you help each other. You guys need to listen carefully because this can be tricky. Now we're all together again, so here we go. We're going to now grab the first layer of the outer right corner. You are going to bring the point to the bottom of the flap so that the point of the triangle lines up with the flap. It's going to make a very small, tiny triangle. Now let's turn the paper over, and you're going to repeat that same exact step that we just did on the other side. All right, now let's locate the section of paper just below the last fold. You're going to grab the corner using the top layer only. Make a small fold towards the center. Turn the paper over and repeat the same step on this side. After you have completed that, you should notice that there is a tip at the bottom of the paper. Carefully grab the top of the paper, and you should notice a small opening. You will gently open your egg. Carefully push out the edges of the paper from the inside. If you are able to push everything out, you will have created a beautiful origami egg. And congratulations on following the wonderful algorithm and creating your egg. Wow, that was pretty amazing. Hopefully now you'll all have your own Alexander egg at your desk. All right, so I want you guys to take about 5 minutes to talk about the process that you followed, or the algorithm that you followed when creating this. Was it easy? Was it hard? Did you communicate with some of your partners near and around you for help? Did you collaborate on helping each other finish their eggs? All right, do your eggs look the same? All right, take a few minutes and talk about that with your partners. Now that you and your partner have had the opportunity to discuss what it was like to follow that algorithm in creating your origami egg art, I want you to think about what it involved. Did it involve problem solving? Did it involve creativity? Did it involve collaboration with a partner near you? Did it also involve communication? Those 4 C's, they keep coming back. And remember, this algorithm is a form of technology that is needed in problem solving to make things better. So now that you had a chance to have a conversation with your elbow partner, I want you to take your journal out and make a few notes about your experience with the origami art and how it connects to an algorithm. All right, now that you guys have finished writing that down, it's time for us to put away your egg, not you, Alexander. Put away your journals, go ahead and put away your pencils. Now I'd like to introduce you to a few more students from CBU. They're going to talk about how they used algorithms, how they used debugging, as well as the 4 C's to work with their teammates to create these amazing projects at CBU. Enjoy!
I'm Johanna Chesler Cortez. I'm a computer science student here at CBU, and it's my senior year, so I'm really excited.
I am a junior this year, and I am majoring in civil engineering.
Very good. And what hopes do you have for a career in the future?
In the future, I want to go into land development. I have a little bit of experience with that from last summer. Just absolutely loved the work that they did, working with development plans for commercial, residential areas, and would love to go into project management in that industry.
Yeah, so something that I've learned that I really enjoy is just all the sciences, and I think data science is a really great opportunity for me to really get involved in different projects, different research, while also focusing in computer science and using all that background from my university. So it's just something that is really exciting. You're constantly working to solve problems for these scientists and that they can actually implement and provide to the public.
Very good. So I hear that you have had a pretty amazing internship. You want to tell us a little bit about what you're doing?
Sure. In June of 2021, I started my internship at NASA Goddard, and through that, I've been involved with some of the earth science research that Goddard is doing, specifically on fire and data visualization. And so the main idea of the technology that we're working on is to provide more information to the public through like your local firefighter department and like public policymakers, so that they have a better idea of what risks are around in your area in regards to fires.
I see we have this amazing canoe here. Is this your project?
Yeah, so we built a few different canoes this year. We've got one over here and one over here behind me. So yeah, for this canoe, it's about 1,000 pounds or so, and they each took about a week to construct.
Okay, very good. And so did you work with a team to create this, or is this something you did independently?
Yeah, so we worked with a team. There was about 12 or so of us. There were 2 project managers, including myself, and yeah.
All right, so as a project manager, what were you responsible for?
As a project manager, I was definitely responsible for kind of starting the project off and getting my teammates all having their specific tasks and how we were going to kind of go about conquering this project, as it's such a big one. Kind of giving people tasks of working on the report and working on design, calculations, all of that kind of stuff.
Very good. Okay, so you mentioned calculations. So one of the things our 6th graders are learning about this week is algorithms. All right, so did you use algorithms in the creation of these canoes?
Yeah, so for these canoes, there are a ton of rules and regulations that the competition has for us. So to begin, we kind of had to start off by reading all those rules and regulations, reading them and having a really deep understanding of each one. And after that, we were kind of able to figure out, okay, how much weight does this canoe have to hold in the water? Kind of estimating that out, we kind of guesstimated about 700 pounds it has to be able to hold. And then after that, we had to kind of go back and forth and kind of debug a little bit with creating different dimensions for the length, the depth, the width, everything like that, because we had to get the water line, which is where the water hits the side of the canoe, to a certain point, so that way the canoe will actually float.
I would say we use algorithms quite a bit in data science in general. The majority of machine learning and AI is built on analyzing and developing efficient algorithms, right? And basically what you want to do is get the program to run efficiently while also giving you the data that you need, and you're hoping to analyze huge amounts of data. You don't want to do that by hand. So.
And so once you use an algorithm and you enter this data in, have you ever come across some errors that you've had to quote unquote debug?
Oh yeah, absolutely. Sometimes it's as simple as like, oh, we just need more data to feed this basically AI, so it has a better understanding of what type of variables we're looking for. Okay. Sometimes you just have to go back to the drawing board and review what you're trying to find in the data and see what you can feed it.
Is there anything else that you'd like to share with us that you think that our 6th grade students could be inspired by or interested in learning?
Yeah, I think something that I've learned over the entire undergrad career, you just have to keep trying and really find what you're passionate about. And if you're passionate about anything or everything like I am, you can find something to get involved with all of that. And I think computer science was the path for me because it allows me to get involved in everything.
Working with a group of people that I am giving tasks to, and being okay with relying on my team members, hey, I need this done, can you please do this for me by this time, this date, type of thing, and being comfortable with being in that type of position.
Very good. All right, well, Victoria, thank you so much for sharing your project with us. We appreciate it, and wishing you and your teammates the best of luck in your challenge.
Thank you.
All right. Well, Alexander, I sure hope that you enjoyed listening to some of the students from CBU, and hopefully they've given you some potential ideas on careers that you might want to consider in your future.
Definitely have some food for thought. Technology is really a lot more than just computers and video games.
You are right, Alexander. Technology is the use of science in solving problems. And remember, that involves the 4 C's, the power of yet, algorithms, and debugging. All right, boys and girls, now it's time for us to talk a little bit more about computer science. Coding is a great example of computer science. What you're going to do now is you're going to take out your devices. You are going to complete this plugged-in hour of code activity to apply what you have learned about algorithms. There is a link here. It will be projected here on the screen, and your teacher can share that with you. You guys will have about 20 minutes to work on that, unless your teacher wants to give you less or more time. Enjoy! All right, and our final activity for the day, boys and girls, is the choice board. The choice board is being given to you in the form of a bit.ly. If you've never used a bit.ly before, you need to be aware that it is case sensitive, which means you have to type it into your Omnibox exactly the way that it appears on the screen. On the choice board, you are going to find some additional coding opportunities, as well as links to other careers that involve technology. You also have the opportunity to complete an additional origami art activity. So, thank you so much for being here with me today. I hope you enjoyed our time together, and good luck, Alexander, in finding your future career.